Hello. During this video, I'm going to show how it's possible to mix a different messaging technologies in an IoT solution for different purposes. So, for example, I'm going to show how it's possible to mix the usage of Apache Kafka for ingesting data from devices using an IoT gateway in this case, and even the Kafka Streams API in order to do some real-time analytics on the data that we are going to ingest from the devices on the field, and at the same time how to use some traditional messaging technologies and protocols, like for example NQP 1.0, an open source and standard protocol heavily used in the messaging world, which can be used for the specific purpose of connecting the IoT gateway to the cloud instead of using the Kafka protocol or having a direct connection to Kafka, as I will explain in a bit, and even for using this kind of protocol for the command and control part. So having the cloud service on the right hand side sending some commands to the IoT gateway in order to do some actions on some actuators as it happens in the real world. So let's see how this kind of IoT solution is made. On the left side I have different Bluetooth devices. For this demo I'm going to use a single Texas Instruments sensor tag, which is a device providing some different kind of sensors, like for example temperature, humidity, and so on, and I'm going to use just the temperature for the purpose of this demo. This device is connecting to an IoT gateway using Bluetooth PLE. In this demo I'm using my laptop as an IoT gateway, and the IoT gateway software is made by Node-RED. Node-RED is a platform for making flow programming, so using different nodes for getting messages, sending messages, and so on. So I'm going to use a node for getting data via Bluetooth from the Texas Instruments sensor tag, and then I'm bridging using another kind of node, as we will see in a bit, for sending this data using the NQP 1.0 protocol to the cloud. On the cloud side, so on the right hand side of this picture, we have an OpenShift cluster, and I have used different projects here. First of all, we are connecting from the gateway to the cloud using NQP 1.0, and ingestion component for getting the connection and for getting the data from the devices is using the QP dispatch router, which is a router using NQP 1.0. Then all the messages got by via NQP 1.0 are bridged using a Apache Camel application from NQP 1.0 to Kafka. So we are running an Apache Kafka cluster in the OpenShift, and this cluster was deployed using the StreamZ project. StreamZ is a project providing an operator, a Kubernetes operator, an OpenShift operator for deploying in a really simple way Apache Kafka on OpenShift and Kubernetes. So we have this Apache Kafka cluster getting this data from the devices through NQP and then through the Apache Camel application. Then these data are processed by a Kafka Streams API application, and they are then showed using a vertex-based application with a web UI in order to control what's happening on the device, right, and the data that we are ingesting. At the same time, you are going to use this sort of control monitoring console for sending back some commands from the console using Vertex to the QP dispatch router to the IoT gateway. So in this picture, first of all, we can see that we are not going to connect the IoT gateway directly to Kafka, so having the Kafka protocol intelligence on the IoT gateway, because in general most likely we are going to use some more standard and open source protocols on an IoT gateway, like for example NQP 1.0 in this case, but it could be even NQTT 3.1.1 for example. Even because as we know on how the Kafka protocol works, it's needed that all the Kafka brokers running inside the Kafka cluster, so in this case even on OpenShift, need to be exposed from outside for being accessible from the IoT gateway. And at the same time, the IoT gateway has to establish different connections with all the brokers in the Kafka cluster for sending data. In this case, instead we are going to use just one connection, just one NQP 1.0 connection from the gateway to the QP dispatch router as an entry point for the cloud part of this solution. And we are going to use the multiplexing feature of the NQP 1.0 protocol, so using multiple links inside the single connection for sending data from these different devices in one way, but on the way back we are using another link for getting commands from the monitoring control. So with just one NQP.1 connection, it's possible to send the data from the device to Kafka, and then getting back some commands from the cloud service to the IoT gateway. So let's see how this solution is working. But first of all, we have to say that we are going to use two different topics for that, Kafka topics. The first one in an IoT temperature topic, where all the temperature value are ingested from the devices. Then this Kafka Streams API application, we will see the code in a little bit, is just doing a simple work. So in a window of 5 seconds, it processes the data from the IoT temperature topic and processes the maximum value. If this value is higher than a threshold, which is 20 degrees in Celsius, it will send a message to another topic, which is the IoT temperature max topic, and this information will be showed to our console, to our monitoring console. So starting from the cloud side, we have this OpenShift web console, where you can see the Streams cluster operator, which I used for deploying my Kafka cluster. So we have a Kafka cluster with the 3 brokers, alongside with the Zookeeper ensemble with the 3 nodes, and then the entity operator, which is in charge to handle using the built-in topic and user operators for handling topics and users in a Kafka cluster. Then we have the QP dispatch router. The QP dispatch router, which is listening on the 2 standards NQP port. So as you can see, the NQP port and the NQP-S port, because in this picture we can see that the Camel application is connecting to the QP dispatch router from inside the cluster, so we are not going to use any kind of encryption in this case, but the IoT gateway needs some more security, so we are going to use TLS for connecting from the outside, so from the IoT gateway to the QP dispatch router running in the cloud. Then after the QP dispatch router, we have this stream application doing the real-time analytics, as we can see. Then we have this control application. The control application using this route is accessible through a web UI, where we can see on the left side there are some information about a Kafka consumer joined a group in order to read information from the IoT temperature max. which is the output topic of our Streams API application. And on the right side, other than a few log about the Kafka messages, we can see a sort of really simple dashboard for sending some commands to the IoT gateway. So on this side, the Vertex-based application is using a Vertex Kafka client, a consumer for getting data from Kafka, and on this side is using an NQP client, the Vertex Proton client, in order to send commands to the IoT gateway through the QP dispatch router. The last application is the Camel NQP Kafka application, which is in charge to bridge between QP dispatch router, so NQP 1.0, and Kafka, so bridging the messages from the device to the Kafka for ingesting this data. On the IoT gateway side, we have this Node-RED application, this Node-RED flow. In this flow, as you can see, I'm using this sensor tag node, which is trying to discover my Texas Instruments sensor tag that right now is a turn off, is not turned on. Then there is this node in order to get this data and building an NQP message and send then this NQP message to the QP dispatch router using this NQP sender node. At the same time, we have another node, NQP receiver node, which is in charge to get messages from the cloud via NQP as command and control step, and then it will just show the messages to the debug console here on the right hand side. So taking a look at, for example, at these two nodes, we can see that they are both using the route of our QP dispatch router and a single endpoint. So it means in Node-RED terms that they are using just the same connection. So we have just one connection established from Node-RED to the QP dispatch router, and these two different nodes, the sender and the receiver ones, are using the same connection but two different links. So the sender will send data to the IoT temperature address, while the NQP receiver will get messages to the control address. Now, in order to see how it works, we can just turn on the Texas Instruments sensor tag and see that it will connect to the sensor tag node, sending the temperature and humidity value in this case, but I'm going to use just the temperature value, and then sending the information to the cloud. So what I've done is just I turned on my sensor tag here, as you can see in webcam, and now this sensor tag is connected to the Node-RED flow. So the sensor tag node says me that it's connected, and as you can see, is getting data, the temperature and the humidity value we are tracking to the debug console, but at the same time we should see all these messages flowing to the QP dispatch router to Kafka using the Camel application, and then via the Kafka Streams API. As you can see here, now the data coming from the sensors are analyzed by the Streams application, and then we will have the temperature, which is 23 degrees in this case. I can just try to rising up a little bit the temperature, and as you can see, the Bluetooth device is now sending new values for that. So here the log of all the messages that we are getting from the sensor tag, and the flow from the gateway to the cloud is working. Now, in order to see or to control the IoT gateway for sending commands to the IoT gateway, we can, for example, click on these two buttons. So for example, let's click on command 1 and command 2, and in the debug console of Node-RED we should see here these two messages received by the NQP receiver node. So we are actually sending some commands to the IoT gateway that then could drive any kind of hardware connected to the IoT gateway in this case. So we are showing how all the stuff is now working. But let's take just a look at the code of the main pieces that we have in this application. First of all, we can take a look at the streams application. As you can see here, this application is getting messages from the topic temperature. So I am building a case stream in order to get the data from the topic temperature. I'm grouping by the key, which is the device ID. I'm windowing by the window that I'm using for processing data. In this case, it's 5 seconds. I'm reducing in order to get the maximum value in my streams. And then I am filtering in order to have just the output message sent to the IoT temperature max when the max value is in this 5 seconds window is higher than this temperature threshold. The other piece of code is related to the camel application and the control application. The camel application, for example, here has a route which is listening on an NQP endpoint, and it's through this processor. It's just transforming the NQP message in a Kafka message where the key will be the device ID and the body will be the same. So in the NQP message we have the body that will be just the body of the corresponding Kafka message. So from this topic, processing the message is now sending the information to Kafka, so to the destination Kafka topic, which is the IoT temperature topic. This is the Bootstrap server for connecting to Kafka, and these are just information about the route ID and logging the body that it's receiving. The last application is about controlling. This is a more complex application, but the main parts are about the command and control. Here, the command and control is using a Proton client, connecting via NQP to the Qubit dispatch router, and when from the user interface a command is received, then this command is just sent using an NQP link to the Qubit dispatch router, and then through the only one connection to the gateway itself. So these are the pieces that are making this solution working. So in this video we saw how it's possible to mix different technologies for different purposes in an IoT solution. On one side, the Kafka and the Kafka Streams API for ingesting data, for storing this data, and then for doing some real-time analytics on this data. And on the other side, the NQP 1.0 traditional messaging protocol, which can be used for command and control, for controlling the IoT gateway, but at the same time as a way for connecting the IoT gateway to the cloud, in order to avoid opening more connections from the gateway to the cloud, but just using one and then using the multiplexing feature for handling all the stuff.